Hi guys, Dr. Tracy here, and I'm going to walk you through the rest of this chapter that we're working on this week, which is data storage formats that we started last week. Hopefully you got the announcement I sent you, because this week we'll be continuing with part B. Now part B starts about halfway into the book, so if you go look at the book, here we are about halfway in at using C programs to explore data formats. Now, this is important. This book was designed for if you had a Raspberry Pi. It is still a very good book, but there is some superfluous information because it's expecting you to have a Raspberry Pi. This first paragraph is absolutely that. We do not need to use a makefile. This is not important. And in fact, you don't really need to know a lot about C because it's going to give you everything you need to type in. And then you just need to understand why it produces the results that it produces. Like in this case, it says most programming books start with a hello world program, but since you already know about integers, we will start with a program that prints both an integer and a float. And since we're talking about data formats, this is a pretty basic program. You can see the comments up here are just describing it. The include is for your standard input output. Here's the function within C. This is going to create an integer called an int. Set it equal to 190888743. And a float called a float, set equal to 19088.743. Now we have a printf statement. You may not be familiar with printf statements, even though you can use them in C++, you don't have to. The printf statements are native to C though. And so what this says is it puts our formatting into our print statement. This says the integer is, and then it has a %d, and the float is %f. Okay, that means that we're going to have that the first number will be replaced by this value, and the second number will be replaced by this value. And so that's just what printf does. You put out the whole statement, and then you put the variables at the end. So the result of this should just say the integer is, and of course here's what the result would look like. The integer is, and you should see that result. So try putting that in. Now, try putting it in. If you do it like this, then you have to be on a Raspberry Pi, or at least something that has Linux. And I don't need you to do that. For right now, I just want you to focus on the results of what is going on in this program. So instead, you can go to a program like Replit. And in the program like Replit, you can sign up in code, but you can just click on C and create a REPL that's going to have that code in it. Again, it's not important to know the code because you could just copy and paste it to see how it works. This is not a programming class. This is a computer architecture. So what you're trying to do with this is you're trying to understand how the computer works, not necessarily how to learn C. I tried to copy it and it didn't copy. Hold on, copy, go to here. I'm going to get rid of their sample. I'm going to put my own in. And there it is, exactly what's on the screen. And if I click on run, you see I'm getting the result that I wanted to get. Now at this point, if you have put in your username and password, which I did not for Replit, I could have saved this program and then been able to go back and work on it later. That's how you could submit the assignments. All right, so that's just showing that we have the float and we have the integer. But then you'll see that the results are coming back that the float is a far different number than what we actually put in, so 0.742188.743. There's really a lot of possibilities of errors that can be compiled because of the ways that numbers are stored in data. And floats are much more volatile than integers, because that comes up the same. So this is going to just kind of explain to you about the reasons for that. The variables on the screen using printf, okay, that's describing that. They're using a conversion code which takes each side of the decimal place and puts it in its own value and number. Now, the conversion codes here, now we're dealing with unsigned integers. Unsigned integers means it can be positive or negative. That gives you twice the data storage for one type. If you're not going to use negative, you use unsigned. And so again, there's this code here that shows how to illustrate how to read numbers from the keyboard. So I'm going to copy this guy and I'm going to paste it into a new replit probably, but I'll just copy over this. Now, when I run this program, it's going to say enter an unsigned decimal integer. Well, any number that's not negative and based on a decimal is going to be an unsigned decimal integer. And then enter a bit pattern in hexadecimal. So entering a bit pattern in hexadecimal comes from the previous chapter where we were talking about that. And so by entering a bit pattern in there, we're trying to show what the value would be in hexadecimal. So once you put in the programs, the programming exercises start here. And this is where your homework assignments are going to be. It says enter the program in listing 2.9.2 and test it. Use exercises 2.6 to test the program. All right, so listing 2.9.2 is going to give you that whole code. The one that's there before, you can copy, you can paste it. I'm not worried about you using the C language, but I want you to know what's going on. Then it says use exercises 2.6 to test the program. This is exercises 2.6 because these are binary and decimal and hexadecimal conversion. So that's what it means when it says use those examples. To submit this project, I need to see your C program or at least screenshots. You can share the link, but I also need to know that you used these values to test it. You could show me screenshots of that, or you could describe what happened, what answers, what results you got. Using the program in 2.92, how many bits are in the largest unsigned integer that is supported by this program? You know, they do have hints and they do have answers. And obviously, you can look at them if you get stuck. But do not submit the answer word for word, what they have in the answer. I will completely mark it wrong. If you have to look at the answer and I don't know, I won't be able to control you, yes or no. I'm looking for you to answer this in your own words. Please don't copy and paste the answers. Then it says modify the last printf statement so that the hexadecimal value is displayed in signed integer format. So you're just going to change that printf statement to a different format, and then you'll modify it so that it addresses the x and y variables that should be displayed in hexadecimal. And so you're taking all the conversion stuff for the first part of the chapter and you're doing them with C. Now, it continues to look at some programming exercises in here, but I'm going to stop with that. You will examine memory with the debugger by using some of these commands. Again, the commands that you're using, you can copy and paste. You're not going to be using the Linux to do some of the break. If you, I think we might need to skip this because we don't have, hold on. Oh yeah, we skipped that examining memory with the debugger. Don't do this one because you need a Raspberry Pi to get GDB. So skip 2.11. We are not doing the 2.12 exercise. Skip that. Going into storing characters. This is using string manipulation. So instead of working with integers and floats, this section of it talks about the bit patterns of characters and what each of these things stand for. And it's going to just describe the way that binary under hexadecimal representation can contain contents that mean letters. There's programming exercises to do with that. Write a program in C that creates a display similar to. And again, there's a hint and a solution. Just make sure that you get this working and add your comments so that I know that you understood it. Low-level character handling is this next section, 2.15. And this is going to use printf to display low-level characters like command line prompt or a file name. And then there's programming exercises in that. So that's the assignment for this week. It's just using C to help understand how a computer reads data storage formats. Let me know if you have any questions about this. I can walk through this with you a little bit further, but I think since most of the homework assignments have hints and solutions, you probably will be okay. If you get stuck, I'll be happy to help. I'll talk to you soon.